Hello, this is Matt Gaskill. This is a sample presentation for problem 1.18.8, Philosophy 160. In this problem, we're asked to construct a common truth table for several arguments. And what we're trying to understand is the properties of an exclusive OR operation. So we're using this underlined OR symbol to mean or in the exclusive sense. And so what we've done is we've constructed a truth table for the arguments that they want us to look at. So in this case, it's the A exclusive OR B, the negated A biconditional B, so A if and only if B, and then we've got A if and only if not B, and then not A if and only if B. And so those are the arguments we're looking at, and we only have two variables, and so our truth table is only has 4 rows. So we've got the variables A and B. We've got our standard truth table set up, TTFF and then TFTF. And then for each of these questions, we've first set up with, say, for instance, the argument A exclusive OR B. Then we just simply map over the values for A. So T for A, row 1, T, F, and F. And these are, we'll make them lowercase so that we don't confuse them with the answer to the dominant operation. And then we'll do the same mapping for B. So the B is true in the first row, false in the second row, true in the third row, and false in the fourth row. So we just map those down. And then we go ahead and we answer the exclusive OR question, which exclusive OR is either the left input or the right input must be true, but only one of them can be true. So in this first case, because they're both true, then the result for the exclusive OR is false, because they're not kind of A can be true or B can be true, but not both. And so in this case, because they're both true, then this exclusive OR results in a false. Here we have just A, just the left input is true. The right input is false. And so we end up with a true value. And then we have the opposite situation. In this case, A, or the left input is false. B, the right input is true. So again, the exclusive OR case for that is true. And then because neither the left nor the right are true, then the exclusive OR is false. Now, and then we continue on. We can look at the next set of arguments. The setup is the same. So initially for the A column, we just map over TTFF, TTFF, and then we map over the B, TF, TF, etc., like that. And then we do the if and only if. And so that's going to be when the left input and the right input are the same. So they don't necessarily have to be true, but they have to be the same. So here, T and T, that's the same. So this is going to be a true. Here, T and F is different. So we end up with false. F and T, again, different, but in a different way. And if we end up with false, but here we've got false and false. So since they're the same, then we end up with a true value for the operation. And then that entire line, what we've done is the parentheses we kind of ignore. And so to show that we're ignoring, we just put an underscore in those places. But now we've got the value of this this piece which is the center value, TF, TF, or TFFT. And so now we need to negate it or switch it. So all T's become F's, all F's becomes T's. So this was a T, now it becomes F. But because it's the dominant operation, it's capital F. And then we switch the F to a T, again, the F to a T, and then here we go with T to an F. And so we end up with false, true, true, false down the line. Over to the next one, the setup's the same. We just fill in the columns for A and the columns for B. They're just simply mapped over from our kind of our input column. And then in this case, though, we have to be aware that when we have a negated B like that, because which of those two operations do you do first? So you have to understand that there's kind of like unseen, unspoken parentheses that kind of wrap around when you see this negation like that. And so we have to negate the B first. That's the first thing we have to do for this piece. And so we go on the line, we convert, and again, when negation is just flipping, so that T flips to an F, this F flips to a T, this T flips to an F, etc. And now when we look at the operation, if and only if, we're just simply looking at those values. So on the left is a T, the right input is a false. Again, they're not the same. So this operation requires them to be the same. Left and right have to either both be true or both be false. If they're not the same, then the overall operation's false. So in this case, T and F, they're false. Here's T and T becomes true. F and F is true because they're both the same. Left and right inputs are the same. But here, F and T, left and right inputs are false because they're different. On this last one, it's the same idea. We have to negate the A first. And so we end up with the T becoming an F. T becomes an F again. F becomes a T. F becomes a T. And now we have to, when we're evaluating this the dominant operation here, the if and only if, we have to understand that our left input is this last value that we figured out. So each value can only be used once. So we used this T a moment ago and we negated it. So once you use it, that's it. You don't get to use it again. So the only one available to us on the left is this false, and on the right is this true. And so because F and T are different, then the value of the biconditional is false. Here we've got an F and we get a T and an F again, and so they match, and so we end up with a T. And then again, we got a T and a T, they match, so we get a true. But T and an F, they're different, they don't match, and so the overall is false. And now we've got the truth table done, and we can look at each row, and I've changed the colors so that only really the important dominant operations, the dominant values, are what you can see in the black, and then our worksheet behind the scenes work is in the gray. But you can see in like row 1, we get an F, an F, F, and an F. And row 2, true, 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 true. Same for row 3. And then in row 4, we have an F, F, and F. So all of these are logically equivalent. They all result in the same truth values. And so that's our conclusion, is that they're all logically equivalent. If you have any questions, hit me up on Pronto. Thank you.